Hello, so in this video we're going to be showing how to make Lewis dot structures for ionic compounds. So we learned in the last video how to make Lewis dot structures for just a single element, and now we're going to be showing how to put those together to make the Lewis dot structure for an ionic compound. So I've got two different ionic compounds here. The one on the left is calcium fluoride, CaF2, and the other one is potassium oxide, which is K2O. So to make a Lewis dot structure for an entire compound, you have to start by making the Lewis dot structures for each elements, and then we'll make our ions, and then we'll combine those to make our whole compound Lewis dot structure. So let's start with the calcium fluoride. We've got one calcium atom. So to make our Lewis dot structure, we've got two valence electrons on the calcium, so we put 1, 2 dots. They're on different sides because remember we don't put the dots grouped together until we get past 4 dots. And now we've got 2 fluorines in our formula, so we've got to do the Lewis dot structure for 2 fluorines. So we've got our 2 fluorines. Each of them has 7 valence electrons. So you should have 3 sides that each have 2 dots, and one side that gets 1 single dot. So those are all our Lewis dot structures for the calcium fluoride. Now if we go over to our other example, to our potassium oxide, we now have 1 oxygen. So I'm going to draw that one in the middle. Oxygen's got 6 valence electrons. So we go 1, 2, 3, 4, 5, and 6. And then we've got 2 potassiums, and I'll put 1 on each side. Got our 2 Ks. Each of them has 1 valence electron. So those are all of our Lewis dot structures for our compounds, or for our elements, excuse me. So the next thing that we're going to do is we're going to show how these ions are created. So the calcium, in our first example, wants to lose both of its valence electrons. It wants to drop down to the previous energy level to get to that 8 valence electrons so that it'll be stable. So to do that, calcium is going to donate one of its electrons over to fluorine and the other electron over to the other fluorine. That way it loses both those electrons and it's happy. And those fluorines have 7 valence electrons. They want to gain 1 more to get to 8. So by taking 1 each from the calcium, they're going to reach that set of 8 and they're going to be happy. Over in our second example, we've got potassium that wants to donate its 1 electron to drop down to the previous energy level. And we've got oxygen that wants to gain 2 electrons to get up to 8. So this calcium is going to donate an electron to oxygen. This one's going to do the same. So now we're going to move down here. We have calcium. And since it's lost its electrons, we're going to draw some brackets around it. This is going to show us that this calcium is not the same calcium that we had up here. It's not that neutral calcium. Since it's lost electrons, it has a +2 charge. So we write that +2 up there to show it's lost both of its electrons. And then we're going to go ahead and do the same thing with fluorine. Since it's gained electrons, it's not the same neutral fluorine. Remember, we got 2 of them. 1, 2, 3, 4, 5, 6, 7 around each of these. And then I'm going to draw this last electron in green to show you that those electrons were calcium's electrons, but now fluorine has them when it makes this ion. And since it gained that extra electron, each of these fluorines has a -1 charge. So you've got 2 fluorines with a -1 charge, makes a total of -2. The calcium is a +2. There's one of those, so our +2 and -2 cancel. We've got a neutral compound. So that is our Lewis dot structure for calcium fluoride. For our other example, we've got our oxygen that has 1, 2, 3, 4, 5, 6 valence electrons it had before, and then it's got those 2 electrons it gained from potassium. So then we go ahead and we draw our brackets, and it now has a charge of -2 because it's gained 2 electrons. And then we're going to draw each of our potassiums. So this K lost its electron, so it now has a +1 charge. And then we have another potassium over here that lost its electron and has a +1 charge. So we've got 2 potassiums, each with +1. That makes a total of +2. The oxygen has a -2, so we've got a neutral compound. So that's how you draw your Lewis dot structures for ionic compounds.